Okay, so this is investigation 2, and what it's asked, it gives you a triangle, A, B, C, and it tells you it's an equilateral triangle, and that you're supposed to draw the segment CD, which is the altitude. So it's an equilateral triangle. I marked it already. Now we need to draw an altitude. Okay, so I'm supposed to draw the altitude in CD. So this must be D down here. Okay, and so the altitude, if you remember, the altitude goes from the vertex, to the opposite base and is perpendicular. Okay, so there it is there. Now we also learned in chapter 5 that the altitude in an equilateral triangle is also, so we learned that the altitude is the same as the median, and it's the same as the angle bisector, and it's the same as the perpendicular bisector. It's all 4 in 1. All 4 of those are the same thing. Now I'm going to use the fact that it's an angle bisector in this, but you could have used one of the other 2 facts to prove it. And what that tells me is this angle is the same as this angle. Now you got to go back to equilateral triangles, the definition. For equilateral triangles, we also know they're equiangular. So we know this is 60 degrees, this is 60 degrees, and the angle C at the top is 60 degrees. But we just said it's an angle bisector, so we know this is 30 degrees, and this side is 30 degrees. And what you'll see is that you now have, I'm only doing one of them, this orange triangle is now a 30, 60, it's a 30, 60, 90 right triangle. There's another one on the other side that's there as well. So we've got that there. And it says, what are angle A and B? Their measurements. Well, I just showed you they're 60 degrees. The second question says, what's the measure of angle ADC and BDC? So A to D to C, and B to D to C. Well, it's an altitude, so they know they're right angles. So we've answered question 2. Okay, I'm going to erase those out. Okay. Number 3 says, what's the measure of angle ACD and BCD? ACD, BCD. Well, we already figured that out because it's an angle bisector. The 60 degrees is turned to 30 degrees. And then number 4 says, is triangle ADC congruent to triangle BDC? Well, that's going to be a little bit of thinking. We're going to have to go back to chapter 4. And one of the things we have is this altitude is a side in both of them. Okay? It's a side. Then we notice that we have a right angle, and we had a right angle here, so there's an angle. Whoops. And then we notice that we had, originally the triangles were 60 degrees in each angle of the equilateral triangle, so that's 60 and 60. So in fact, we have an A. So yes, triangle ADC is congruent to triangle BDC by SAA, triangle congruency. And then it asks, what do you know about AD and BD? Well, if the triangles are the same, are congruent, then we know this is the same as this. And so that means D, we could call it the midpoint. It cuts it in half.